Good morning, dear students. My name is Ferhan Mazher, and today is 22nd March 2021, and the day is Monday, and the subject we are studying is Physics 5054. And today we are going to solve a theory paper. We call it paper 2. We will solve today October-November 2014 2-1 paper. This paper 2 belongs to Zone 1. And in this session, in this video, we will be solving its section B only. Section A, we have already solved. It's in my YouTube channel. If you check the playlist, you can find this. And I hope that this will be helpful to you. Let's go to the section B. And so here we go. Okay, on your screen, this is section B of October-November 2014 2-1 paper. Section B starts from question number 9. Figure 9.1 shows the dam and reservoir of a hydroelectric power station. A hydroelectric power station uses a renewable energy source. State two other renewable energy sources. So it's a 2-mark question, and you just have to state. You only have to state 2 names of the renewable energy sources. So one can be the wind energy and the other can be the geothermal energy. Wind energy and the geothermal energy. I have the marking scheme as well. Let me show you the marking scheme. Question number 9, A part on your screen. I hope that you are able to see this. Yeah. So you can name anything for biomass, wood, geothermal, solar power, tidal power, wave power, wind power. Any 2 names you can. You can name any 2 things. They are renewable. Okay. So the next question on your screen is question number 9, B part. When the power station operates at full capacity, the electrical power output is 6.8 expo 9 watt. Calculate the electric energy output of the power station if it operates at full capacity for 1 year. So we want to find out the electric energy for 1 year. The power is given, the electric energy can be calculated. You know, the energy is equals to power multiplied time. Power multiplied time. But the time must be in seconds. But they gave you the time in years. So what we will do, we will convert a year into seconds. So in 1 year, there are 365 days. You multiply it with the 24 and then you multiply with the 3600. So the time should be converted into seconds. And then use the formula energy is equals to power multiplied time. And you will get the answer in joules. Let me show you my work. I have done this on a paper. Let me show you. So let's start. Okay. So here we go. So the first, I don't know whether this is visible to you or not. I hope that you can see this. The power is given at 6.8 into 10 raised to the power 9 watt, and the time is 1 year. To convert the time into seconds, what I will do, because there are 365 days in a year, and there are 24 hours in a day, and there are 3600 seconds in 1 hour. So I will multiply them. So I got 31536,000 seconds. Then I will use the formula energy is equals to power multiplied time. So energy is 6.8 expo 9 multiply 31536,000. And my answer will be, if you use your calculator, the answer will be 2.14 expo 17 joules. 2.14 expo 17 joules. I think it's very simple. I hope that you have understood this. Let me show you the marking scheme. marking scheme. So let's see the marking scheme. So here you can see the first part. It's a 1 mark question, and I hope that you have understood this numerical. This was the B first part. B's second part is first, and its second portion is suggest why in practice the power station does not operate at full capacity throughout the year. The word is suggest. So we will suggest that why the power station cannot be operated at full capacity throughout the year. You see, it's a hydroelectric power station, and the hydroelectric power station depends upon the supply of the water. And the supply of the water depends upon that how much rain, how much we have the rainfall in the year. And you know, the rainfall is not same throughout the year. It is not uniform throughout the year. Rainfall, we have some rainy season, then we will have lot of rain and lot of water in the dam, but in we have some months when there is no rain, especially for example, in Pakistan, especially, you know, when it's winter, the snow is not melting on the mountains, so there will be a shortage of water in the dams. And in the summer season, when the snow is melting on the mountain, then we have a lot of supply of the water in the dams. So you see, this depends upon the supply of the water. So you can suggest that why you cannot operate fully throughout the year, on full capacity throughout the year. The reason is that it depends upon the supply of the water, and the supply of the water is mainly the melted ice and the rainfall, and they do not remain constant throughout the year. I have written this answer. Let me show you my answer. And so let me show you my answer. Rainfall varies during the year. So this is my answer, which I have written. I doubt that this is visible to you. And let me check the marking scheme. What the marking scheme says: anyone from not enough water to maintain maximum flow. Rainfall varies during the year. Periods of low demand. So very simple. It's a 1 mark question. I hope that you will be able to write this answer. The 2 lines are given for this answer. I hope that you will be able to write this answer. Okay, ji. Then we have B second, and its first. The water surface in the reservoir that supplies the hydroelectric power station is at a vertical height of 170 meters. Above the turbines, in 1 hour, 1.6 expo 10 kg of water flows from the reservoir through the turbines. The gravitational field strength G is 10 Newton per kg. Calculate the gravitational potential energy that is converted into other forms of energy in 1 hour. Okay. So I know the mass of the water which is flowing in 1 hour, and I know the height from which the water is falling, that's 170 meters. And I know the value of the G. I can find out the gravitational potential energy, the loss in the gravitational potential energy. That will be given by the formula mgh. So I know the value of the m, I know the G value, I know the H value. Just put these values in that formula and you will get the answer. I have done this. It's a 2 mark numerical. I have done this on a paper. Let me show you. And this is showing on the screen. So potential energy is equals to mgh. The value of the m is 1.6 expo 10, and the value of the G is 10, and the value of the H is 170. Just multiply them. The final answer on your calculator will be 2.72 expo 13 joules. So this much potential energy is lost by the water in 1 hour. So let me show you the marking scheme. The B second first part. You can see it's a 2 mark numerical. The final answer here, you can see this. This is 2.7 into 10 to the power 13 joules. I hope that you have understood this. Okay. So The second part is to calculate the efficiency of the power station when operating at the full capacity. You see, the input energy is the gravitational potential energy and the output energy is the electrical energy of the power station. The electric energy was given to us, and the electric energy was given to us, and the input energy we just calculated. So we can find out the efficiency, but there is a problem. The problem is that the output energy which we have just calculated, that was for complete 1 year. In the B first part, we calculated the electric energy output that was for 1 year, and the input energy we just calculated in the second first part, that is for 1 hour. So their time duration is different. So that's the trick in this question. Basic trick is this. Actually, if you want to find out the efficiency, the formula is very simple. Efficiency is useful output energy divided by input energy multiply 100. So the efficiency formula is simple, but there is only one problem, that the output energy we have calculated, that is for 1 year. I need to convert it into the electric energy which is produced in 1 hour. So I can calculate that, and the energy which you just calculated for 1 year in the B first part, you divide that with 365 and divide it with 24. So then you will get the output energy for one hour. And then it will be very simple. I've done this on a paper. Let me show you. Yeah. So on your screen, it's showing. I can hope only that this is visible to you. And you see, it says input energy is given 2.72 expo 13 joules. This was energy for 1 hour. And output energy, that is 2.14 expo 17 joules. But this energy was for 1 year. So I will convert this output energy for 1 hour. So for that purpose, I will divide it with 365, because in 1 year we have 365 days, and then again I will divide it with 24, because in 1 day we have 24 days, 24 hours. Sorry. So when you divide it, you get the answer 2.443 expo 13 joules. Then, if you want to, now you have the output energy for 1 hour. You can find the efficiency. The formula for the efficiency is useful output energy divided by input energy multiply 100. The useful output energy, that was electric energy for 1 hour, is 2.443 expo 13 divided by 2.72 expo 13, and you multiply it with 100. Your answer on the calculator will be 89.8%, which is approximately 90%. So the power station is 90% efficient. I hope that you have understood this numerical and you are able to do this. If you have a hard copy in front of you or you have a notebook, kindly do this numerical. The only problem in this numerical was that the input energy we calculated, that was for 1 hour, and the output energy we calculated, that was for 1 year. That's the main problem in this numerical. So let me show you the marking scheme, and on your screen you can see here you have that marking scheme. The final answer is 90%. So hopefully you are able to understand that how this numerical is done. Okay, the third part is suggest 2 reasons why the efficiency of the power station is less than 100%. You see, we just calculated that the efficiency of this power station is 90%. The question is why it's not 100%. You see, the power station has some energy losses. And they are asking you to suggest reasons why there are energy losses, why the power station is not 100% efficient. Some energy is wasted. The reasons can be many, but we can name here a few. For example, if you look at carefully, all the gravitational potential energy of the water, that was converted into the kinetic energy. and all the kinetic energy of the water, it is not converted into electric energy. One very simple way of knowing this is that the water which is passing through the turbines, and they are rotating because of the flow of the water. And when the water which enters into the turbines, it's at very high speed. But when you look at the water which is exiting the turbines, the water which is coming out of the turbines, that still is at very high speed. So you will immediately came to know that the water which came out of the turbine still has lot of kinetic energy in it. It means that the water which is coming out of the turbine, it has lot of kinetic energy. It means that it has not given all its kinetic energy to the turbine and to the generator. So that can be the one suggestion, one reason, that the water which is coming out of the turbine still has lot of energy, kinetic energy in it. That can be one reason. The other reasons can be that turbines, they are rotating and they are rotating the generators. The turbine, they have bearings in them, and in those bearings, and in those bearings we can have friction. And when you overcome the friction in the bearings of the turbine, your energy will be converted into heat energy, which will be lost to the surrounding. So that can be the second reason. Another reason can be, when the generator produces electric energy, and because in the coil of the generator there is a resistance, and due to that resistance, some electric energy will be converted into the heat, and that will be lost to the surrounding. Let me show you the marking scheme, and then I will show you. You see, the marking scheme. Now, the marking scheme is on showing on your screen, and let me increase the size. Let's see, this is okay. So any two from the friction of the water with the pipe or turbine, viscosity of the water, friction at the bearings, resistance, heat in the wires, kinetic energy of the water leaving the turbine. So you can suggest any reason from the given reasons. It was a 2-mark question. I have written this answer in my here you can see. Let me increase the size. Okay, so the water leaving the turbines have kinetic energy. That can be the one reason. The other reason, bearings in the turbines have friction. To overcome this friction, heat is produced, which is lost in friction. Heat is lost in the form of heat loss. I had written the wrong sentence. So heat is produced, which is lost to the surrounding. That's a loss of energy. Okay, question number 9, and then we have its C part. He says before the electric energy is transmitted along the power lines, the voltage is increased to a very large value. We step up the voltage. State and explain why a very high voltage is used to transmit electric energy over long distances. You see, for example, in a power station, when the electric energy is produced and then it is transmitted to the consumer. So we have transmission lines which are bringing the electricity to your homes, to the consumer. And so before sending the electricity to the consumer, what they do, they make its voltage very, very high. At the power station, they use step-up transformer, and they make it the voltage very high. And when you use a transformer and you increase the voltage, you see that the amount of current will decrease. Why we do this? You see, when the electricity is passing through the transmission lines, due to the resistance of the transmission lines, what happens? The electric energy converts into heat energy, and that heat is dissipated and it is lost to the surroundings. So this is a power loss. This is energy loss in the power lines, transmission lines. So if you want to reduce that loss of energy in the transmission lines, so there are two methods. One method is reduce the resistance of the transmission lines. To reduce the resistance of the transmission lines, it's very difficult, it's very costly. If you want to reduce the resistance of the transmission line, you know what you have to do. You have to increase, one method is to increase their diameter, their cross-sectional area. That will be very, very costly. Another method is change the conductor. For example, if you use a better conductor, for example, you can use copper, and copper will be very, very expensive. So to change the resistance, it's very difficult. It's very costly. So what another method is, the power loss is given by the formula. Power loss is equal in the transmission line is equals to I square R. The formula, remember this formula. Power loss in the transmission line is I square R. So one factor is R, so we cannot change it. So let's concentrate on the I thing. That's the current amount, the amount of current which is flowing. When using a transformer, you increase the voltage. What happens? The amount of current decreases. So when the amount of current will be less, the power loss will be also less. That's why we use we increase the voltage by the help of the transformer to decrease the amount of current in the transmission lines, and this reduces the power losses in the transmission line. It's a 3-mark question. So let me show you my answer, and then we will check the marking scheme as well. Here you can see I have written the answer. He says that step up transformers step up voltage in the secondary coil. The current in the secondary coil becomes smaller. Power loss in the transmission lines is given by the formula P is equals to I square R. When I decreases, power loss in the transmission lines also decreases. So let's check this from the marking scheme, and the marking scheme says, let's see what the marking scheme says. Okay. So it's a 3-mark question. You can see on your screen, it's a 3-mark question. 1 mark is for telling that the less energy lost or wasted, or it is more efficient. This 1 mark for saying this. For a given power, a high voltage results in a smaller current, and when you increase the voltage, the current decreases. 1 mark is for telling this thing. And less heat generated if the wires or I square R, or less resistive losses, not if chain resistance mentioned. Okay. So hopefully you have understood. So how you will get this? This is a 3-mark question, and now you know that the 3 points which need to be mentioned in your answer. I have also read my answer, so I hopefully you will be able to write a good answer of this question. That was a 3-mark question, and it's a very, very famous question. Remember this thing. State the name of the device that is used to increase the voltage in the power station. When we want to increase the voltage, we use step up transformer. What we use step up transformer. Let me show you the marking scheme. What it says, he says transformers. Okay. So the next part is explain why the generators in the power station must be AC alternating current generators. You know, the transformer that only works on an AC supply. In the primary coil of the transformer, we need to provide alternating current, and then the transformer will induce EMF in the secondary coil. So the transformer only works on the alternating current. So that's why the generators in the power station should be producing alternating current. Let me show you my answer. I have written here. The transformer can work if AC supply is fed into the primary coil of the transformer. Let me show you the marking scheme as well. Transformer only works with an AC supply. Transformer only works with an AC supply. It's a 1-mark question. So my dear students, that was the question number 11. Sorry, question number 9. I said question number 11. We are doing today October, November 2014 and 2-1 paper. And that was in this video, we are doing the section B of this paper. We are done with question number 9. Let's go to question number 10. The casing of electric kettle is made of white plastic. Figure 10.1 shows the heating element positioned in the base of the kettle. And okay, so I think that we have to stop here for a reason. We will continue this and I need to go somewhere. That's why I have to stop. I will do this video from question number 10. I will start again. So, my dear students, my name is Ferhan Mazher and I'm back. We were doing October-November 2014 2-1 paper. And we are in this session, we are working on the section B of this paper. And I was working on question number 9, we have already done. And now we are working on question number 10. The question number 10 is showing on your screen. The casing of an electric kettle is made of white plastic. Figure 10.1 shows the heating element positioned in the base of the kettle. And let me reduce the size so you can see the whole question. The heating element supplies thermal energy to the water at the bottom of the kettle. Describe and explain how the thermal energy is transferred throughout the water. You see, the heating element will produce heat. The water near this will absorb this heat and the water molecules will move away from each other. The water will become less dense and this less dense water will rise upward. On the top, the water which is relatively colder, that will be relatively denser. That water will sink. In this way, the convection currents are set up in the water, and by those convection currents, the heat is distributed throughout the water. It's a 3-mark question and a very famous question. So on your screen, I hope you will be able to see this. It says water near the heating element absorbs heat and it becomes less dense. Less dense water rises and cold and dense water sinks. This set in convection currents, or you can say set convection currents in water. This way heat is distributed throughout the water. This is a 3-mark question and hopefully you will be able to do this. And let me show you the marking scheme. Here we have the 10A first part. One is a 3-mark question and 1 mark is for telling that heated hot water expands, the density of the heat and hot water decreases. 1 mark is for saying that the heated or hot water will rise, it rises, and 1 mark is for telling that the convection current circulation set up or heated or hot water rises and the cold water sinks. So you see it's a 3-mark question and the marking scheme is showing on your screen. I have also shown you an answer written by me, and you can write a better answer, but keep these 3 points and you will be able to write a good answer which can secure good full marks. Okay, the next part is on your screen. It says explain why a kettle with its heating element in the water at the top of the kettle does not heat the water uniformly. You see, the heating element is always put in the bottom of the kettle. He says his question is, if I put the heating element on the top of the kettle, why this is not a good idea? Because you see the convection currents moves in the upward direction, the hot water moves in the upward direction. So if you have put the heating element in the top, the convection currents cannot be set up in the water. So the heat cannot be distributed. It's a 1-mark question. Explain why a kettle with its heating element in the water at the top of the kettle does not heat the water uniformly. It's a 1-mark question. I've shown you, let me show you my answer. And my answer is hot water moves upwards. If heating element is on the top, convection currents cannot be set up. This is my answer. Let me show you the marking scheme as well. The marking scheme here you have this answer. The marking scheme says convection transfer heat upwards or less dense heated or hot water already at the top. So you can write this answer. It's a 1-mark question. Okay, next question is on your screen. He says that The kettle is powered by a 230-volt supply. It is switched on for 3.5 minutes and there is a current of 9.6 ampere in the heating element. Calculate the thermal energy produced in the heating element. If you want to calculate the thermal energy produced, the formula is very simple. Energy is equals to IVT, where I is the current, V is the voltage, T is the time, but the time must be taken in seconds. So formula is IVT. I is given, that's 9.6 ampere. The V is 230 volt and the time is given 3.5 minutes. But in this formula, the time must be taken in seconds. So I will have to convert 3.5 minutes into seconds. For that purpose, you will multiply 3.5 with 60 because in 1 minute there are 60 seconds. So use this formula. E equals to IVT. I've done this on a paper. Let me show you my working. And here we go on your screen. So on your screen, that numerical is showing E is equals to IVT. The value of the I is 9.6 ampere and the value of the voltage is 230 volt. The time is 3.5 minutes. I will multiply it with 60 to convert it into seconds. So my final answer will be 4.64 expo 5 joules. 4.64 expo 5 joules. I hope that you have understood this. Let me show you the numeric, the marking scheme as well. B first part on your screen. Hopefully you can see. Q is equals to VIT and you put the values. The final answer will be 4.6 expo 5 joules. I hope this is I think 2 marks numerical and you are able to do this. Okay, the next part is the kettle contains 1.6 kg of water that was at an initial temperature of 22 degrees centigrade. The specific heat capacity of the water is 4200 joules per kg per degree centigrade. Calculate the maximum possible temperature of the water. You see, I know the mass of the water, I know the initial temperature of the water, I know the specific heat capacity of the water, and I also know from my previous calculation that how much energy is being transferred to the water. So when there is a change in the temperature, we can use the formula heat is equals to mc delta theta. Heat is equals to mc delta theta, where heat means the heat you supplied, m means the mass of the water, c means the specific heat capacity, and delta theta means the change in the temperature. So we will put these values here and we will calculate how much is the change in temperature. And from there, I know the initial temperature, then I will be able to find out the final temperature. So on your screen, B second part calculation is showing. You can see that I have written there that heat is equals to mc delta theta. Heat is 463680 equals to mass is 1.6 kg. And the specific heat capacity is 4200 joules per kg per degree centigrade. And delta theta is the question. So delta theta will be equals to 69. Delta theta, when you will do this calculation on your calculator, you will get the answer 69. And you know delta theta means change in temperature. That's final temperature minus the initial temperature. I know the initial temperature. Initial temperature is 22. I want to know what is the final temperature. So final temperature will be initial temperature plus the change in temperature. So that will be 69 plus 22 and the answer will be 91 degrees centigrade. So after you have provided this much heat to the water, the new temperature or the final temperature of the water after the heating will be 91 degrees centigrade. I hope that you have understood this. Let me show you the marking scheme as well. So B second part, the marking scheme showing on your screen. I hope that this is a 3-mark numerical and it's not difficult. Heat is equals to mc delta theta. I hope you have understood this, how this numerical is done, a famous numerical. Okay. The next question is suggest one reason why the temperature of the water after 3.5 minutes is less than the value calculated in the piece. We just calculated that the rise, the new temperature after heating will be 91 degrees centigrade. But their question is in actual, the real temperature which will be showing that will be less than 91 in actual practice. In practical, when you will heat that electric kettle, the water in the electric kettle for 3.5 minutes, the temperature will be not 95, it will be less than 95. Theoretically we calculated that should be 91 degrees centigrade, but in reality it will be less than 91 degrees centigrade. His question is why. So that's a reason. You see, when you are providing heat in the kettle to the water, there are many ways in which the heat is lost to the surrounding. Not all the heat which you provided will go into increasing the temperature of the water. Some heat is lost to the surrounding. So we have to suggest a reason, a way in which for example, the process of evaporation. When you are heating the water, the temperature of the water is rising, and during that the rate of evaporation will also become faster. So when the rate of the evaporation will become faster, so what will happen? The water will lose. The water will be lost by the evaporation. So when the water is lost by the evaporation, you see what happens. Actually, the energy is also lost in the evaporation. The evaporation process is taking away your energy. So due to this, there will be a loss of energy. I have written this answer. Let me show you. During heating, due to evaporation of water, heat energy is lost to the surrounding. That's my answer. So during heating, due to evaporation of water, heat energy is lost to the surrounding. Let me check the marking scheme. It's a 1-mark question. Not very difficult. You see on your screen, this is showing 1-mark question. Evaporation of thermal energy, heat in the plastic casing, element surrounding air or environment. It's a 1-mark question. I hope that you will be able to write that why the actual temperature rise will be less than 91 degrees centigrade. Actual final temperature will be less than 91 degrees centigrade. So let's move to the next part. Explain one advantage of using the plastic for the casing of the kettle. You see that electric kettle has water, it has electricity in it. So if you are using a plastic casing for that electric kettle, that's a good thing. Because the plastic is insulator of heat. Plastic is also the insulator of electricity. So if the casing is made of plastic, the chances that you will get an electric shock that reduces. And because it's also insulator of heat, so you will burn your hands by just touching the electric kettle. That also reduces. So using a plastic. Let me show you my answer. I have written this answer also. It's just a 1-sentence answer. And it says a plastic casing is insulator of electricity, so there will be no chances of electric shock. Plastic casing is insulator of electricity, so there will be no chances of electric shock. So let me check the marking scheme. You see, we are poor conductor, heat of electricity or less heat loss, cooler to touch or less risk of the shock. It's a 1-mark question, very easy to answer. Hopefully you have understood. The second part is choosing white as the color of the outside of the casing. You see, if this is electric kettle, it has hot water in it. So its temperature is more than the surrounding. So if the color of the outer side, the color of the kettle is white, you know the white color is a bad emitter of infrared radiation. White color is a bad emitter of infrared radiation. So the loss of heat by the radiation will be reduced if the outside color of the kettle is white. So I have also written this answer. Let me show you my answer. And on your screen, hopefully you can see this. White color is a bad emitter of infrared radiation. So heat loss by radiation will be reduced from electric kettle. You know, the electric kettle is has hot water. Its temperature is more than the surrounding. So white color will reduce the heat loss by the radiation. On your screen, see second part. You can see the answer on the marking scheme: poor emitter and less heat loss of radiation or infrared radiation. Okay, you are not supposed to write poor absorber because the kettle is hot and the surrounding is cold. So here the process of heat emission is taking place. So don't use the word poor absorber. The kettle is not absorbing heat from the surrounding. D part on your screen. D part is showing. The kettle is switched on again and the water reaches its boiling point. It starts to boil and the kettle remains switched on. State the meaning of the boiling point. Boiling point means the temperature, a specific temperature. You know that during the boiling point, the temperature will not change. Boiling point means the temperature at which a liquid will convert into gas at 1 atmospheric pressure or at standard pressure. The temperature at which, the specific temperature at which a liquid starts converting into gas form at 1 atmospheric pressure. That temperature is known as boiling point. Let me show you my answer. I have written this answer. And you see, specific temperature at which a liquid converts into gas at standard atmospheric pressure. Specific temperature at which a liquid convert into gas at standard atmospheric pressure. So let me show you the marking scheme. Temperature where liquid and vapor or gas coexist, or where liquid, not substance, boils. At atmosphere, don't say substance boils, say a liquid will boil. At atmospheric pressure, allow become vapor or gas. So it's a 1 mark, definition, very famous definition, frequently asked in the papers. Explain in terms of molecules what happens to the thermal energy that is supplied when the water is boiling. Explain in once again, I am back. My name is Ferhan Mazher. We are doing October, November 2014 2-1 paper. In this session, we are working on the section B of this paper. And because it's raining outside and when the electricity goes, the electricity is coming and going. So what happens? We have our internet is interrupted. So due to this, you see, we have problem. I have to stop. So we were working on question number 10 and we were on the last part of question number 10. Hopefully, we were doing the D part of question number 10. D part says that D part says, state what is the meaning of the boiling point. I have already told you it's the specific temperature at which a liquid will convert into gas at 1 atmospheric pressure. The next question, the second part was explain in terms of molecules what happens to the thermal energy that is supplied when the water is boiling. So when the water is boiling, the energy which you supply, the thermal energy which you supply, that is used to overcome the intermolecular forces, that is used to separate the molecules from each other, and that is used to increase the potential energy, that is also used to overcome the atmospheric pressure. It's a 2-mark question. I have written this answer, and let me show you my answer, and then we'll see what is in the marking scheme. Question number 10, and it's D, second part. It says the thermal energy is used to increase the potential energy and separate the molecules from each other. It is also used to overcome the intermolecular forces. Thermal energy used to increase the potential energy and separate the molecules from each other. If it is also used to overcome intermolecular forces. Let me show you the marking scheme. What the marking scheme says. The marking scheme says, here we go. So the second part, the answer is showing on your screen. Work done against or overcoming forces between the molecules, or molecules gain potential energy. Don't say here the increase in the kinetic energy. The reason is the temperature do not change. When the temperature do not change during this process, the kinetic energy will also remain constant. And change to potential energy or molecules separate. So it's a 2-mark question. I hope that you will be able to write its answer. So we are moving to the next question. That question is question number 11, that is showing on your screen. A student makes a 2-volt battery by connecting 2 cells of electromotive force, or EMF, 2 volt in parallel. The battery and ammeter with different ranges and 3 different resistors are used to set up the circuit shown in the figure 11.1. So you can see that here we have 2 cells which are parallel to each other. When the cells are connected in parallel to each other, and their EMF do not add up, the EMF will remain. The first question, 2 volt, explain what is meant by electromotive force. There are 2-3 definitions of the electromotive force. One is the amount of chemical energy converted when you're especially talking about cells. The EMF means the amount of electric energy which is the amount of chemical energy which is converted into electrical energy when one unit charge or 1 coulomb charge flows through the battery. And another definition can be the amount of work done by the battery or by the cell to move unit charge in a closed circuit. The amount of work done by the cell to move unit charge in a closed circuit, that is called the EMF of the battery. I've written this answer. Let me show you my answer. So on your screen, it is showing. Let me show you. The answer is showing on your screen. It says the amount of work done by cell to move unit charge in a closed circuit is called the EMF of the cell. So let's move to the next part. The next part says, state one advantage of using 2 cells. State one advantage of using 2 cells in parallel rather than using a single 2-volt cell. When you put the cells in parallel to each other, the life of the cells become longer. They last longer. Okay. The next question is resistor X and the 3 ohm resistors have a combined resistance that is equals to 2 ohm. Calculate the total resistance. So let me take you to the. He's saying that the combined resistance of these two, is 2 ohm. Here we have another 2 ohm resistor. So what will be the total resistance? They will be in series with each other. So 2 ohm and 2 ohm here. So it will be 4 ohm resistance. The total resistance will become 4 ohm. So it's a 1 mark numerical. B second part is the resistance of X. You know, these two, they are parallel to each other. Their total resistance, he told us, is 2 ohm. Now he wants me to find out the value of the X, the resistance of the X. So we can use this. I have done this on a paper. Let me show you. So this is B first part. The equivalent resistance will be 2 plus 2, 4 ohm. So now he has told us that these two, their combined resistance is 2. So the equivalent resistance is 2 ohm. So because they are connected in parallel, the formula for finding the equivalent resistance when the resistors are connected in parallel is 1 by R equivalent is equals to 1 by R1 plus 1 by R2. So 1 by R equivalent will be equals to 1 by 3 plus 1 by X. And we know their equivalent resistance, that is 2 ohm. So 1 by 2 equals to 1 by 3 plus 1 by X. 1 by 3 will go on the other side, it will subtract. So 1 by X equals to 1 by 2 minus 1 by 3. So take the LCM or do this on the calculator. On your calculator, write 1 divided by 2 minus 1 divided by 3 equals to, press the SD button and you will get the fraction. So 1 by X equals to 1 by 3. So cross multiply and X will be equals to 6 ohm. So the value of the X, this resistor X, the value of this resistance will be 6 ohm. I can hope that you have understood this because they were connected in parallel. So we use the formula 1 by R equivalent is equals to 1 by R1 plus 1 by R2. Let me show you the marking scheme as well. Here you can see the marking scheme for the question number 1, first part, and question number 11A, second part, and question number 11B, first part, and question number 11B, second part. So have a good look at the marking scheme as well. So hopefully you can do these numericals and the A, first part, and second part. So the next question is C, first part, determine the reading of the ammeter. You know, the ammeter is connected here. The ammeter is actually telling you the amount of current which is coming out of the battery. You know, the total resistance of this whole circuit was 4 ohm, and the voltage of the battery is 2. The voltage of the battery is 2 volt, and the total resistance of the whole circuit is 4 ohm. So I can use the formula V equals to IR. The voltage of the whole battery, the whole circuit, or the voltage of the battery or EMF is 2 volt. I know that, and the resistance is 4 ohm. The total resistance of the whole circuit is 4 ohm. So use the formula V is equals to IR. I have done this on a paper. Let me show you my work. And yeah, so V is equals to, let me change the size. V is equals to IR. I is the question, the reading on the ammeter, and the voltage of the battery is 2, and the total resistance of the whole circuit is 4. So 2 divided by 4 will be 0.5 ampere. So 0.5 ampere current is coming out of the battery. Their next question is, okay, suggest a suitable range for the ammeter. You know, the reading, the current coming from the battery is 0.5 ampere. So any ammeter who can measure up from 0 to 1 ampere, or from 0 to 2 ampere, or from 0 to 3 ampere, from 0 to 5 ampere will be good. The range can be from 0 to 5, it can be from 0 to 3, it can be from 0 to 4, it can be from 0 to 1 also. Any number you can tell. Because the current coming from the battery is only 0.5 ampere. So the range can be from 0 to 5, or it could be from 0 to 4, or the range of the ammeter could be 0 to 3. Very easy question. The D part is the current. The current in the 2 ohm resistor is I2, the current in the 3 ohm resistor is I3, and the current in the X is IX. State the equation that relates the I2, I3, and the IX. Let me show you the diagram. So I2 current is coming from the battery and I2 current is passing through this 2 ohm resistor. Here the current will split. I3 current is passing through this and IX current is passing through this resistor. So I3 here, IX here, and here the I2. So I2 will be equals to I3 plus IX. I2 will be equals to I3 plus IX. Let me show you my work. So I2 will be equals to I3 plus IX. Okay. So let's move to the next part. We will look at their marking schemes later. Okay. The next question is state the potential difference across the 2 ohm resistor and the 3 ohm resistor. So, you know, the question is how much is the voltage drop here? 2 ohm resistor. What is the voltage drop here? I know the resistance here. I know the current flowing from here. The current flowing through this resistor is 0.5 ampere. And I know the resistance, so use the formula V is equals to IR. V is the question. The resistance is 2 ohm. The I value is 0.5 ampere. Just put the values, multiply them, and the answer will be 1 volt. So across this resistor, the voltage drop will be 1 volt. From the battery you brought here, from the battery 2 voltages are coming. 1 volt will be used here on this resistor. 1 volt will be used here. Very simple. Let me show you my work. I've done this. See, how do we calculate this? Very simple. So, IE first part, V is equals to IR. The current flowing through the 2 ohm resistor is 0.5 ampere. The resistance is 2. So, just multiply them. You will get 1 volt. Very easy question. The next question is the next question they ask is what is the voltage drop across the 3 ohm resistor? You see here we have just calculated that the voltage drop across here will be 1 volt. 2 volt is coming from the battery. So if 1 volt is used here, these two are connected in parallel. It's a conceptual thing. Try to understand this thing. These two are connected in parallel, so both of them will have the same voltage drop. And the total voltage drop will be also same. So because from the battery 2 volt came, 1 volt was used here. So for this combination, we will have 1 volt. So 1 volt will be used here, 1 volt will be used here. The total voltage drop here will be again 1. Okay. When you are connected the resistors in parallel to each other, the total voltage drop on them is equals to the individual voltage drop when they are connected in parallel to each other. It's a conceptual thing. Try to understand this thing. Because they are connected in parallel to each other, the voltage drop on the 3 will be 1 volt, the voltage drop on the X will be 1 volt, and the voltage drop across this combination will be also 1 volt. And how I came to know that 1 volt? Because from the battery 2 volts were coming, 1 volt was used here, which we just calculated. So how much voltage is left for this combination? 1 volt. Because they are connected in parallel, so whatever is the voltage drop on this combination, same is the voltage drop on each individual branch or each individual resistors, because these resistors are connected in parallel to each other. Conceptual thing. Try to understand this. Okay, the next question is F part. Let me show you the marking scheme. So how we have done. V3 will be equals to 2 minus 1, and that will be 1 volt. We will see the marking scheme at the end. Okay. So here it says the student sets up a second circuit using a variable DC power supply, an ammeter, and a 12 volt metal filament lamp. So this filament lamp is taking 12 volt. The circuit is shown in the figure 11.2. The DC power supply is set to 12 volt and the ammeter reading is 1.5 ampere. So when the the voltage the voltage which you provided to the lamp is 12 volt. The current which is flowing through the lamp is 1.5 ampere. The student changes the EMF of the DC power supply to 6 volt. The lamp dims and the ammeter reading changes. State and explain what happens to the resistors of the filament, the metal filament of the lamp. You see, when you will reduce the voltage from 12 volt to 6 volt, the power dissipation or the power used by the lamp, that will reduce, that will become half. So the lamp will become dim. When the lamp will become dim, its temperature will drop. When the temperature of the filament lamp will drop, its resistance will also decrease. Okay, so that when the voltage reduced from 12 volt to 6 volt, the temperature of the filament will drop and its resistance will also decrease. That's why it has become dim. It's a 2-mark question. I've written this answer. Voltage has dropped due to this. Current will also decrease. So the temperature of the voltage has dropped due to this. The current will also decrease. So the temperature of the filament will decrease, and so will its resistance. The resistance will decrease because the temperature of the filament has decreased. Let me check the marking scheme because this thing is a little confusing. So here we go. Temperature decreases, resistance decreases. The next question, a very technical question, it is state whether the new ammeter reading is less than or equals to or greater than 0.75 amperes. So try to understand this concept. You see, when the voltage was 12 volt, the current was 1.5 ampere in the filament lamp. When the voltage provided was 12 volt, the current flowing through the lamp was 1.5 ampere. Then what you did, you changed the voltage, you made it 6 volt. So the voltage is kind of, you have halved it. You have made it 1/2. You have it. So if you have the voltage, half, the voltage has become half of the previous value. So automatically in your mind, it will come that the current will also become half. From 1.5 ampere, the current should become 0.75 ampere. According to Ohm's law, this should happen. If the voltage is reduced to 1/2 of the previous value, the same thing should happen with the current according to Ohm's law. But the important thing is that the filament lamp is not an ohmic conductor. That thing could have happened only if the lamp was an ohmic conductor. If its resistance have remained constant. But you see, if the voltage will become half, the current should have become also half. 1.5, it should have become 0.75 ampere, but it will not happen. Why? Because, the filament lamp is not ohmic conductor. Its resistance will not remain the same. Its resistance will reduce. When you will decrease the voltage, from 12 volt, you make it 6 volt, the resistance of the filament lamp will also decrease. So the current becoming half, that will not happen because of the resistance has also decreased. So the amount of current flowing through the lamp will be more than 0.75 ampere because the resistance has also decreased. The resistance of the filament lamp has also decreased. When you will reduce the voltage, the temperature of the filament lamp will decrease, so its resistance will decrease. So the current will not become half. From 1.5 ampere, it will not go to 0.75 ampere. It will be little more than this. So you only have to state. I was explaining why this will happen, but you only have to state here. The current will be more than 0.75 ampere. I have written this answer. Let me show you my answer. Reading on the ammeter should be more than 0.75 ampere. That's my answer. So look at the marking scheme. It says the reading on the ammeter should be greater than 0.75 ampere. So that's it, my dear students. And this paper is over. And let me go back and okay. So today we have worked on October-November 2014 2-1 paper. It's a theory paper. We call it paper 2. And in this session, we have worked on its section B only. In the section B, we have question number 9. We have solved it. Question number 10 and question number 11. We have done 3 questions. And section A of this paper, we have done in another video, in another session. You can find that in my YouTube channel. And hopefully this is helpful to you. If you are watching this video, I believe that if you have a hard copy of this paper in front of you, and if you are watching this video and listening carefully, and you are watching you have your marking schemes and you have that paper with you, and you are writing as you are watching this video, this will improve your grades, your concepts, and it will be helpful to you, especially during this COVID era, when you are not allowed to go outside, you are not allowed to go to school even, and you are supposed to remain at your home. So from the safety of your home, if you are watching this YouTube video, you will be able to learn and you will be able to solve this paper. So that was today's, I think that is enough for today. So everybody, thank you very much. And if you like this video, this video is helpful to you, if this is improving your concepts of physics, kindly like my YouTube channel also. Kindly subscribe to my YouTube channel. And also suggest your friends about this channel. All your friends who are studying in O-levels and they are studying physics, kindly suggest them that watch these videos. So I will, because if you subscribe me, that boosts my energy and I am able to produce and I am able to work harder and harder and make new videos on different papers and to be more helpful. So once again, thank you very much. Have a good day. And my name is Ferhan Mazher.